5054 October November 2021 paper 2 variant 2 section B about hydraulics. Question number 7. Hydraulic press is used to recycle the center to compress waste materials. Figure is a side view of press. So here it is a master cylinder, this is slave cylinder, there is liquid inside it. When the force is applied, the piston 1 is pushed this way, and piston 2 moves downward and apply a force on this way. Okay, a force to the left is exerted on piston 1. Oil is pushed along the pipe and is moved piston 2 downward. Piston 2 compresses the waste. Question A. Oil is a liquid. State the property of a liquid that makes it suitable for use in hydraulic system. The main advantage of a liquid to use in a hydraulic system, it is incompressible, and there are repulsive force between the molecules, and the intermolecular space which is slightly there, right, not in solid, very high in gas. So this make a good incompressible material which provides equal pressure, right, to the to onwards. So state the property of a liquid that makes suitable for use in a hydraulic system. Liquids are incompressible. Question 2. Explain in terms of molecules why liquid has this property. The liquid has this property because they have very less intermolecular space and are more repulsive force between the molecules. Suggest one advantage of using oil as a liquid in hydraulic system. Liquid which are more viscous is very suitable in any hydraulic system. Oil is more viscous and it has a less friction. So that is why it has an advantage from other liquid, especially from. So part C, the cross section area of piston 1 is 0.081 meter square. Piston 1 exerts a force of 4,500 Newton on the oil. So calculate the pressure of the oil due to this force. So pressure equals force upon area, 4,500 over 0.018, that is 250,000, or 2.5 into 10 power 5 Pascal, or 250 kilopascal. The pressure of the atmosphere is 1 into 10 power 5. Calculate the total pressure of the oil on the pipe. So on the pipe. So total pressure is atmospheric pressure plus pressure of the oil, which is 1 into 10 power 5 plus 2.5 into 10 power 5, which is 3.5 into 10 power 5 Pascal. The area of the piston tube that is in contact with the oil is 1.4 meter square. Initially, the upper surface of the piston tube is level with point 2. Calculate the force exerted on the piston tube due to the pressure. Calculated C2. So calculate the force, which is pressure is the same, 3.5 into the power 5 over equals F over 1.4, that is force is equal to the pressure multiplied by the area, so it is 4.9 into 10 to the power 5 Newton. So as the piston moves along the pipe, the pressure of the oil in the pipe at point P remains constant. Point piston 2 moves downward. The pressure of the oil at the upper surface of the piston 2 increases. Explain why the pressure of the upper surface of the piston 2 increases. Piston 2, piston 1 when moves downward, it will increase depth. So whenever the depth increases, pressure increases. Piston 1 move down, increase depth, so pressure increases on piston 2. The density of the oil is 900 kilogram per meter cube. The upper surface of the piston tube is now 0.5 meter below the level of the pipe. Calculate the increase in the force exerted by the upper surface of the piston tube by the oil. Gravitational field strength is 10 Newton per kg. So the difference in pressure will be equal to rho g delta h, means difference in height. So weight is equivalent to force. So delta F is equal to rho G delta H. So change in force rho G delta H into area. So delta F will be 900 into 10 into zero point 0.5 into 1.4, which is 6,300 Newton. So the air trapped in that constant in that contain the waste. The temperature of the air in the bags remain constant, explained in terms of molecule. Why the pressure of the trapped air increases as it's compressed. So we know from the Boyle's law, the pressure and volume are inversely proportional to each other, provided that the temperature remain constant. So when the volume decreases, pressure inside of the bag increases due to the frequent collision of the air molecules. So this will, so that the moon, the most every have a straightforward answer, no big deal. Except from my side, it is D. As the piston one moves along the pipe, the pressure of the pipe of the oil in the pipe at point P, right, remain constant. Piston 2 moves downward. Whenever the piston moves downward, you see the piston move downward. So from P, there is a gain in height. So the gain in height will increase the pressure. You can say the apparent depth, the gain in height, rather than to say height, the depth, right? Yeah, or I can say the apparent depth, or you can say the lateral height, right? The height from the bottom, right, is increases, so piston 2 will receive more pressure.